In this lesson, we would go over the application and thinking problems of derivatives. One of the applications of derivatives is to determine the unknown variables of a given polynomial. So the learning goals of this lesson are to apply the rules of derivatives to write the polynomial function. And we will be writing the polynomial function that will be given to us with unknown variables. So we will be determining the unknown variables of the polynomial function in order to write down the complete polynomial. After going through the lesson, the students will be able to use the given information to interpret the steps to determine the unknown variables for writing the polynomial. The students will be able to use derivatives and critical number information to determine the max and the min points of the graph of the given function. And the students will be able to use the given information to determine the unknown variables using substitution. Let's understand all this with an example. Let's say we're given a function fx is equal to 3x to the power of 4 plus ax cubed plus bx squared plus cx plus d, and we are given that this function has horizontal tangents at -2, -73 and 0, -9. With all this given information, we will be asked to write down this function completely, that is by putting in the values of the variables a, b, c and d. In order to write down the polynomial completely with the given variable values in there, we would first have to understand what is all given in this question and how to interpret and relate it to derivatives in order to determine the constant values of the variables. So first of all, we would look at these points, and we know these are the points where we would see horizontal tangents for this given function fx. Horizontal tangent, as we now know, is definitely going to be seen at a point that we call the max or the min point, and the x for that is going to be called the critical number. Therefore, to write down given, we can say f of -2 means when we substitute -2 into the function, the result we get is -73. This can be written as 3 with -2 to the power of 4 plus a times -2 to the power of 3 plus b times -2 to the power of 2 plus c times -2 plus d is -73. We can simplify all this. So this would give us 16 times 3, 48. This would give us -8a. This would give us plus 4b, -2c plus d is -73. We can simplify it by collecting like terms, and we notice 48 and -73 is a like term. So we can write it as -8a plus 4b minus 2c plus d is -73 minus 48, and that would be equal to -121. So the final equation we would have is -8a plus 4b minus 2c plus d is -121. So we can use this information that this is the point given on this function to rewrite the given function in this simple form. Similarly, we can rewrite the function using this point as well, 0, -9. So that means f of 0 is equal to -9. Now we would substitute in the function x as 0 value, and this is what we would get from the function. So anything multiplied by 0 is all 0. Finally, we would be left with d is equal to -9. We just notice here that d equal to -9 gives us a value of the variable d. So we can write this as one of the values of the given variables. Therefore, we can write down d is -9. Now, one thing we have to remember is that when we are given a point for the horizontal tangents, the x value of the point is also called the critical number. And at the critical number, the derivative of the function is going to be 0. So we can say the derivative of function fx at -2 would be equal to 0. And the derivative of the function fx at 0 is also 0. Therefore, we can write the derivative of the given function and substitute that in the given equations. As the function given to us is 3x to the power 4 plus ax cubed plus bx squared plus cx plus d, its derivative would be 12x cubed plus 3x squared plus 2bx plus c plus derivative of d is 0. And since we know the derivative of the given function is 0 at x equal to -2 and at x equal to 0, as these are the critical numbers, so we would be substituting in the derivative function x -2 and put this all equal to 0. -2 to the power of 3 is 8. 3 times a times 4 minus 4b plus c. So this gives us 96 plus 12a minus 4b plus c is 0. We can move 96 over and we would get -96 is equal to 12a minus 4b plus c. And this is the second equation that we have got so far. We can similarly solve for the derivative function when x is equal to 0. Since x equal to 0 is the critical number, so the derivative will be also equal to 0. And this would give us the c value equal to 0. Reason is that anything multiplied by 0 is 0, so we're just left with c equal to 0. From here, we've got the value of the variable c as well, just like we got the value of the variable d earlier, and that was equal to -9. So we can write the value of the variable c as 0. Now we can use this equation as well as the equation that we got from the derivative function together to determine the unknown variables a and b. Always remember that if we have to determine two unknown variables, we need two equations at least. And if we have to determine unknown variables 3, then we need at least 3 equations. Therefore, the number of variables that we want decide the equations that we should be making. Let's write the two equations that we've got together. So these are the two equations that we have got. The first one was from the original function. The second was from the derivative function equation. So this is the first one and this was the second one. Apart from this, we also know that d is -9 and c is 0. So this can help us write down the equations in more simplified form. That is, the first equation will be -8a plus 4b minus 2 times 0 is 0 plus -9 is a -9 equal to -121. And the second equation can be written as 12a minus 4b equal to -96. We can move this on this side to collect the like terms. This would give us -8a plus 4b equal to -112. And this we see we would get is 12a minus 4b equal to -96. Now since we're left with two equations and two variables, we can either go ahead with substitution or elimination. I'm going to pick elimination here is because I already have a variable b that I can eliminate easily because it has a constant with opposite signs in both the equations. So I'm going to add the two equations. That would give me 4b minus 4b, that cancels out, and -8a plus 12a gives me 4a equal to -208. To solve for a, I would just divide -208 with 4, and this would give me -52, and that's the value of a that I've got. To solve for b, I'm just going to substitute a in any one of these two equations. So let's say I pick the second equation. So 12 times -52 minus 4b is -96. This gives us a -624 minus 4b equal to -96. Minus 4b is equal to -96 plus 624 would be equal to 528, and 528 when divided by -4 would give us 132, and this will be the value of b with us. So we've got a value as -52 and b value as 132. To sum this all up together, we can write down the final function equation as fx is equal to 3x to the power 4 minus 52x cubed plus 132x squared. As c is 0, we need not put 0x. So minus 9. And this is the final function that we have got by using the application of derivatives and critical numbers.